I know, we heard you. Yeah. And that'll be on there. Most everybody else won't be, but yours was loud enough. It'll show up. Okay, I don't know what happened. I don't know why I lost both. Why I lost that. Shoot. Okay. Maybe. It was flashing. They were flashing when I started, right?
Yeah.
Yeah. I don't know what happened. What?
There's a box.
Yeah, like a flash. Wait, is it still recording?
Now it is. Because I started another one.
I don't know what it was a box.
This is really awkward.
I don't know. Okay, all right, well, whatever. We'll figure it out. Okay, so this factors. Jeremy, did you get it yet?
X plus 5 equals plus 1.
How about no x's? How about u's?
Oh, yeah.
Okay, 2u plus 1, and look at that. I said no, I know x's, and I wrote an x. And that's okay. So u plus a 5. Okay, which is going to give us two solutions. U is negative a half, and u is negative 5. Alright, so back, u is 7 to the x, so we have 7 to the x equals negative a half, and 7 to the x equals negative 5. Uh-oh. Can that happen? No, can't happen. This one's out and this one's out. So how about for the whole problem?
No solution.
No solution. No solution. All right. Look at number 10, please. Number 10. Natural log of 2x equals a negative x plus a 2. We need to solve for x here. Any ideas? Bella, got an idea?
Can you possibly like to the E or something like that, or take the E under or something, so that you could like even out the F and
Well, what if we think about this as log base e?
Oh.
And would that work? Is that what you're saying? Kind of get rid of the logs, rewrite it in exponential form?
Yeah, that's what
So, okay, so this would be e to the negative x plus 2 equals 2x. Okay. Now what? Can we do anything here? Solve for x? Are you going to be able to get the x all by itself on one side? Wait, what, Gianna? Okay. To what? Times e to the negative 2. Okay. Wait, what? Positive 2. Okay. Divide both sides by e to the negative x? Okay. So we'll have e squared is 2x over e to the negative x. Okay? Now what? We got the x's all on one side now, but we got to get an x equal. So that means I got to get rid of everything else. Everything else has to move over to the other side. Right? Sure. Like that? Yep. Now what? So close. Divide by 2? Sure. X, e to the x equals e squared divided by 2. Okay. Now what? Gotta get an x equals. No, we did not goof. Everything's perfectly mathematically valid. Everything that we've done is perfectly legal, mathematically. Yes, Gianna, there's no possible way to solve for x. Really? Really? You can't get this. You cannot isolate x because the x is outside of an exponent and it is an exponent. Or initially up here, x is inside of the logarithm and there is also an x outside of the logarithm. It is not analytically possible to solve this.
Is it possible to find this out before
Yes.
you do the problem?
Yeah.
Or do you
I just told you how.
Yeah.
If you got an x inside the log and an x outside the log, you cannot isolate. Okay, so it is not possible to analytically solve this. But don't quit. Try something else. Go back to the original equation. Natural log of 2x equals negative x plus 2. Could you put this natural log of 2x into y1 in your calculator? And could you put this negative x plus 2 into y2 on your calculator? And then do what? Look for points of intersection. Okay, I just put a quick sketch of this up on paper. Should be something like that. Do you? Maybe it's a little flatter on your screen. Yeah, a little flatter, but the same rough idea. Can you find that point of intersection? Kevin, did you find that point of intersection? It is. It is exactly 1.159 comma 8 0.840. Okay, what's the answer to this question though? So they're solving for in the original equation x. So your answer is not the ordered pair. Your answer is 1.159. There's your answer. Okay, so far? Yes? No? Maybe? All right, look at 11. E to the x equals x cubed. All right, same type of thing is going to happen here. You cannot solve this one analytically because you've got the x is an exponent and then an x not as an exponent. Just like up here, we had an x in the logarithm and an x outside. You had an x as an exponent and an x not as an exponent. You can't solve that analytically. You're going to have to graph this one. So go ahead and put e to the x in y1 and put x cubed in y2. Do we see that? A standard viewing window? Yeah? We definitely see a point of intersection right up here. Can you find that one? See that? Of course. Here we go. Okay, so now you see this one right around here, yeah? Okay, but we're going to have to open this window up a bit because there's actually 2 points of intersection. There's actually 2 points. And you know that because of just because you know what exponentials do and you know what cubics do. Here's y equals e to the x. Here's the x cubed one coming up. And I'm probably going to have to open my window up a bit more. The cubic is the red one or the pink one in here. The exponential is the blue one. And at some point, that exponential, it gets so big so much faster. Can you see that those are starting to get closer together up here at the top? I don't know if you changed it or not. Let's go window. I'm going to send this up to 100 and see if that's enough. And I'm going to shrink this down to like 5, I think. Oops, did I want to do that? Oh yeah, I didn't do that. Sometimes with the color calculators, I don't know if anybody else notices, but you hit a button and it does, if you punch buttons too fast, it doesn't register them. Do you know what I'm talking about? Does that happen to anybody else or just me? Okay, I feel better. Alright, so there's one right there. Oh, there's another one right there. You see this exponential starting to really increase super duper fast? You see what I'm saying? Okay, so if you see that an exponential is going to get so much bigger, so much faster than a cubic, then you can find that second point of intersection. But let me show you something else that's another option that you might like a little bit better that cleans this one up a bit. Instead of putting this in y1 and this one in y2, what if we did this? So we subtracted that x cubed over. So now, now what do you look for? You look for zeros. And then you won't have to worry about trying to figure out if it meets it again or not. Does that make sense to what I'm saying? Yeah. So that's a nice option, is to put all of this into y1 and then look for zeros. And there are 2 of them. There's one of them at 1.857 and one of them at 4.536. Make sense so far? Yeah. All right. I'd like to get one more problem in before we quit today. One more problem. And let's do this one. This e to the x plus e to the negative x all over 2 equals 3. Okay, first thing. You guys like fractions?
No.
Most people don't like fractions. Could we multiply by 2 to clear the fractions here?
Yeah.
All right, so let's multiply by 2 to clear the fractions. And that'll give us an e to the x plus e to the negative x equals 6. Okay. And we touched on it a couple minutes ago. What's this e to the negative x? Could we write that as 1 over e to the x? So I have e to the x plus 1 over e to the x equals 6. Yeah? Okay. Even though it doesn't look quadratic, let's do that u substitution right now and get rid of these exponentials. So let's do u equals e to the x. And we're going to see u plus 1 over u equals 6. Now do you have an idea what to do so we're not thinking exponentials anymore? Got an idea? Did you like fractions? Nuh-uh. Could we multiply by a common denominator to get rid of fractions? So what do you want to multiply by this time? U. So u squared plus 1 equals 6u. Now are you seeing quadratics? Yes. So pull that 6u over, bless you. Okay. Factor. Does not factor. Oh man, so what are we going to do?
Quadratic formula.
Quadratic formula. Okay, now be careful. Identify what this is. This is u equals. Some of you forget what variable you're solving for, and then you would quit right at the end of the quadratic formula, and we can't quit right at the end of quadratic. U is opposite of b, so 6 plus or minus the square root b squared minus 4 times a times c all over 2 times a. And we're going to have 6 plus or minus 36 minus 4, 32 over 2. Simplify. 6 plus or minus, what's 32? 4 square root 2? Okay, be careful. I'm grading the test and some of you did not simplify quadratic formula properly. You can cancel out this 2 with that 6 and that 4 as long as you do both of them. You cannot cancel out the 2 with just one of the pieces, because essentially what you're doing is you're factoring a 2 out of the top and then canceling out that 2. If you can go from this line right here, this one, to that one, and divide 2 out of everything, that's okay. If you don't see that, then factor. Factor the 2 out of the top and then cancel. But if you can go from this line right here to that bottom one right here, then you're okay. Does that make sense? Are we done?
No.
No, because what are these answers for? These are answers for you. And we have to solve for x. Oh boy. So we're going to have to flip back. U was e to the x. So now we have e to the x equals 3 plus 2 square root 2, or e to the x equals 3 minus 2 square root 2. Okay, you're solving for an exponent. Flip to log form. X is log base e of 3 plus 2 square root 2, which is the natural log of 3 plus 2 square root 2. So x is the natural log of 3 plus 2 square root 2, or x is the natural log of 3 minus 2 square root of 2. Please go to your calculator and give me some decimal approximations for those. Maybe do you have them? Uh-huh. Yeah, negative 1.762, exactly. There you go. Exact answers, decimal approximations. Okay? Questions? All right, let's stop here today. You know what? Wait, hold on 1 second. I want you, because last night you should have done most of the homework. Today you can do a lot of the exponential equations, things that we haven't talked about yet, just so you know when you're looking at your homework. If you have to solve an equation that's got logarithms in it with different bases, base 2 here and a base 4 here, we've not talked about those yet. So leave those until after tomorrow. So when you're getting going on your homework, if the logarithms have different bases, don't solve them yet. Okay?